Now, since we practiced already how to simplify with some of the trig identity, now we're going to learn how to prove an identity. And this is kind of fun for me. I think of it as solving puzzles, and this is kind of like solving a puzzle to make it look like the final picture. So what we're going to do is we have two sides to a equation, and what we're going to do is not really solving anything anymore. We're just going to do proofs. And this is not like geometry proofs. I know a lot of you are kind of like, no, we don't want to do geometry proofs anymore. Yeah, it's not a geometry proof. This is a algebra proof. Algebra proof is kind of fun, I think, although I also think geometry proofs are fun. So what we're going to do is we're going to change one side of the equation only to make it look like the other side. And the side we're going to change is left-hand side. Okay, so we can only change the left-hand side to look like the right-hand side. You do not change both sides. You cannot change both sides until it's 0 equals 0. Okay, that's not how it works. We're going to prove that the left-hand side looks like the right-hand side. All right, so let's go ahead and try this first one. Prove the identity. 1 plus tangent squared is secant squared. Well, we already know that is true, 1ts. But we're going to prove it anyway. So remember, we can only change the left-hand side. And if you're kind of saying, what is a left-hand side? If you kind of draw a line from the equal sign, there are clearly two sides. So we're going to make 1 plus tangent squared look like secant squared. Well, how do we do that? A lot of times when all else fails, you just change everything back into sine and cosine and then kind of go from there. So tangent squared, if you recall, is sine squared over cosine squared. And a lot of times you may not see where you're going to go next, but just try something. You know, it's not easy most of the time, but once you try something, you'll realize, oh, there's something else I could do instead, and to kind of going from there. So just, I guess the basic thing I want to say is just don't give up, just keep trying. Because even for myself, there are a lot of things I don't know, and I just keep trying anyways. All right, so what we're going to do, kind of the next logical thing is try to add these two things together. And we cannot do that right now because they don't have the same denominator. So we need to make it have the common denominator, which in this case is cosine squared. So we're going to multiply this by cosine squared over cosine squared. Okay, I'm going to kind of do it the long way here, but feel free to take shortcuts later. All right, so now they have the same denominator. We can add them together. So cosine squared plus sine squared over cosine squared. And then this is where you really have to memorize all the identities to make this faster. Cosine squared plus sine squared is 1. So 1 over cosine squared. And 1 over cosine squared we know is secant squared. And we are done. So it looks just like the right-hand side. So on your homework, there's really no work per se, because you just have to show me that you can prove. So if you skip work and just say, the left-hand side is the right-hand side, you basically didn't do the homework. So you have to show your work to see how you get from the left-hand side to the right-hand side. And there are no skipping steps. You cannot go from this step down to this step or this step and just say they're equal. Because if I look at it or your classmate look at it and say, I cannot see a logical way to get there, then it's not correct. You're skipping way too many steps in your head. You gotta write down everything, because you're basically trying to explain to somebody how you get to the end, and you cannot just let them assume. All right, let's have you practice one. So remember, you can only change the left-hand side and make it look like the right-hand side. Go ahead and give this one a try. Okay, so you probably did something like this. 1 plus cosine squared over sine squared. which is sine squared over sine squared. So that's what 1 is, plus cosine squared over sine squared. And then combine them together, sine squared plus cosine squared all over sine squared. Cosine squared plus sine squared is 1 again. 1 over sine squared is cosecant squared. All right, so that's an adequate proof. Next, we're going to go into some things that are harder. All right, so this one, tangent squared minus sine squared, we have to make it look like tangent squared sine squared. Okay, so this is where first you got to memorize your identities. Second, please remember all your algebra rules. So this is where if your algebra was weak when we were doing the complex fractions and the factoring, all that stuff, it's going to show up here and it's going to be really bad. So make sure you go back and review those things. If you're proving here and everything turns out to be 1 or everything turns out to be 0, that means you're killing cats everywhere, or you're just kind of letting things cancel when they're not supposed to cancel. So please be careful. All right, so looking at this, I have no idea what to do. I'm going to change everything to sine cosine because that's kind of my go-to if I can't figure something out. Of course, you can try something else that's more sophisticated, but I'm just going to do this one instead. All right, probably combine these two things together would be the next logical thing to do. Okay, so sine squared minus, no, I will try not to take shortcut. Okay, and then minus sine squared cosine squared over cosine squared. Okay, now combine them together. You get sine squared minus sine squared cosine squared over cosine squared. Now what? So a lot of times you kind of have to look at the finish line. For the finish line is tangent squared sine squared, and then just ask yourself, is it getting there? It doesn't look like it, but just try to do as much as you can before you give up, which I really don't want you to give up. Just try something. All right, so looking at this, what can you do? So probably something has to happen in the numerator. So looking at those two terms, what do you notice that's kind of interesting between them? Hopefully you kind of see that they both have sine squared, right? And when two terms both have something that's exactly the same, what have we done in the past? Hopefully you kind of thought about maybe factoring it out, and that would be the correct thing to do. If you see something that's exactly the same between many terms, then that's something you can pull out of all of them. And pull out, we call that factoring. And so what we're doing is we're taking sine squared out of every term. And taking it out, as a reminder, means dividing that term by that thing. So sine squared, this one, divided by sine squared is going to give me 1. So 1 goes in there. This one divided by sine squared is going to give me minus cosine squared. This is all over cosine squared. Again, please look at the right hand side. Okay, I think I see where we're going to go next. Okay, so I see a tangent square here. I'm going to try to find that tangent square on the left hand side, which is here. Sine squared over cosine squared. So I can do that. Change this to tangent squared. And then this part I can't find a fit, so I'm going to just write it as the same. Well, this is pretty clear that this part must equal this part, but how does that work? Well, let's look at our identity again. Our identity was cosine squared plus sine squared equals 1. Now, this identity is not stagnant, meaning this is the only way you can use this identity. We can move this identity around to get to what we want. So let's kind of think about it. Which part of this identity looks like 1 minus cosine squared? So think about that a little bit. Which part of that identity looks like 1 minus cosine squared? So it is not in there. However, you could move this identity around. If you were to subtract cosine squared on both sides, you would get sine squared equals 1 minus cosine squared. And now we made the identity look like 1 minus cosine squared. And you can move identities around like this because all you're doing is adding and subtracting, and that's totally fine. All right, so 1 minus cosine squared is really just sine squared. And then we're done because it looks exactly like the right-hand side. And you got to show me all these steps as well. All right, next page. All right, let's give this a try. So go ahead and change the left-hand side to make it look like the right-hand side. All right, so not quite sure how you got to your answer, but this is probably the fastest way. So, you could have changed everything to sine and cosine and go from there. It's totally fine. You probably not the fastest way, but it's okay. What I saw when I looked at this problem was I saw that there are two secants, and so I kind of remember from the previous problem, if you have something that's repeating, you can factor it out. So that's what I did, and then from there I thought secant squared is the same as 1 over cosine, and we just talked about how 1 minus cosine squared is sine squared. So let's try that and see if we can get to tangent squared, which we can't. So, that's one way to do it. You could have changed everything to sine, cosine, and then try to combine the two fractions together and then go from there. That's totally fine. All right, so now is the time for you to do both identities. Make the left-hand side look like the right-hand side. So give this a long pause on the video so you can do both of them. Remember, you can only change the left-hand side. Once you come back, I'll show you how I do it. Remember, that is not the only way to do it. There are many ways to do the proof. You just have to make sure it makes algebraic sense. All right, so let me kind of show you how I did one of them. So number 2, so what you want to do is not automatically change everything to sine and cosine. Yes, you could, but a lot of times that is not the fastest way. And in this problem, that will probably be the longest way, and it's an algebraic mess. So try to think of other clever ways to do this. So when you see cotangent plus 1 squared, it's basically telling you that you can't FOIL. And so when you FOIL, you get to this part. And recall that cotangent squared plus 1, so 1 cc, cotangent squared plus 1 is the same as, sorry, I wrote it wrong, cosecant squared. And so 1 plus cotangent squared is cosecant squared. We're left with 2 cotangent, which is the last part of the right-hand side. So this is good. Number 1, there seems to be nothing you can do with 1 minus sine over cosine because it's already in sine cosine. So this is where you have to be a little bit creative. Looking at the right-hand side, you can see that basically it's a kind of a reverse, right? So cosine kind of became on the top, sine went to the bottom, also a sign change happened, right? So you kind of have to think to yourself, how do I get this cosine to the top and what's making it change sign? And so this is a very typical problem where you kind of have to remember some interesting properties from algebra. I guess the factoring part of it to make this a little easier. If you recall, a minus b times a plus b is a squared minus b squared. So we can kind of just multiply by, if you kind of think about it, the conjugate of the numerator. So 1 plus sine squared. And if you ask, why would I want to do that? This is kind of a trick that you just memorize over time, that when you see this form and you don't know what to do, this is something you could try to see if it gets you somewhere. All right, so in the numerator, it's basically a minus b times a plus b. Remember, that's always a squared minus b squared. So this is going to be 1 minus sine squared. In the denominator, almost always do not distribute, because what we're doing is trying to simplify things and trying to make it look like the other side. And if you distribute, it makes things really, really messy, because it's so complicated when you have a lot of things multiplied together. It's better just leave everything factored. All right, so now looking at the right hand side, we got this 1 plus sign in the denominator now. That's great. We need the cosine to go to the top. Now, if you recall, 1 minus sine squared is another version of the changed identity. Cosine squared plus sine squared is 1. And so 1 minus sine squared means we just subtract the sine squared on both sides. Cosine squared is 1 minus sine squared. And so what we can do is change this 1 minus sine squared in the numerator to cosine squared. And you can see that this is very close to the end, because if you just cancel this cosine squared with cosine in the denominator, you get cosine over 1 plus sine. Now, this is not the only way to solve it. The other way to do this, a lot of people chooses to multiply cosine over cosine in the denominator, or cosine over cosine, and you can do it the same way, and you still need this a squared minus b squared to get to the end, but that's another way to get there. All right, this is all the practice for today, so go ahead and try this on your homework.